Okay, now we're doing problem from chapter 3. So the first problem that we want to do is problem 1. What are the x component and the y component of a vector A in the xy plane if the direction is 250 degrees counterclockwise from the positive directions of the x-axis and its magnitude is 7.3 meters. So the vector A has a magnitude which is 7.3 and it's making an angle with the positive x-axis that is 250 counterclockwise to 50. Okay, so counterclockwise. Whenever you do a vector problem, you want to draw the vector on the xy plane. So you have this, and you have 250. So that will be, so the vector is basically pointing in that direction. Okay, so this is your A with a magnitude of 7.3, and the angle here is 250. Okay, because your angle here is in reference to the positive x-axis. So you can readily use this equation. That is, the x component would just be the vector times cosine of the angle, and angle is 250. So you can actually just plug in the numbers. You have the 7.3 times cosine 250, and that will give you negative 2.5. And your y component is a times sine 250, and so you have 7.3 and then sine 250, and that will give you a numerical value of negative 6.9. Okay, so you have this that's in angle and magnitude notation. If we want to express this vector in unit vector notation, you have your A, vector A, that's equal to negative 2.5 I hat, your unit vector notation, and then minus 6.9 j hats. Okay. Now, so this is basically, you can use this, that the x component is the cosine of the angle, and the y component is sine of the angle, provided that that angle is measured from the positive x-axis, which in this case, that it is. There are other ways, to do to find the x and y component, and if your angle, so let's say if your angle is not, instead of given from the positive x-axis, your angle is actually is this angle. How would you do that? How would you use the angle? Let's say this is your angle theta. So if this is your angle theta, so 200 minus 180, that will give you 70. So I say this is the angle 70. So how would you find the x and y components that is measuring from this negative x-axis? So in that case, I would say that you draw a vertical line. You draw a line here. So this is your vector. So you can see that your vector, this is your vector. So it has a negative x component and it has a negative y component, right? So I'm going to move this vector to that side. So in that case, we're going to adopt what we call the small angle. In other words, the angle is less than 90 degrees. And it's measuring not from the x-axis. So in that case, how would you find the x and y? Remember, this is your angle theta. So whatever that's next to the angle is your cosine. So this component will have your A value and then times cosine angle, because it's next to the angle adjacent. And this is basically your x component. So we call that A sub x as equal to A times cosine theta. Now the other thing you want to pay attention to is that because your vectors here is in the negative direction, so you have to put a negative sign in front of it to indicate that. Okay, so you will have negative 7.3 and then times cosine of 70, and you'll find out that is equal to negative 2.5. Okay, so we are consistent. What about your y component? This is your y component. So your y component is basically your A, and then this is opposite to the angle. Whenever you have something that's opposite the angle, it's always sine. So sine of theta, and then again, because you're using smaller angle, and this is pointing downwards, you have to put a negative sign manually. Okay, so what you have here is negative 6.9. Okay, so this just basically tell you that you can you can use this 250 when it is measured from the positive x-axis. If it's not measured from the positive x-axis, then when you're given any angle, then just draw a line that's perpendicular to the axis and then find out what that angle is. Whatever that's adjacent is cosine, whatever that's opposite the angle, that is your sine. And then you have to actually manually put a negative sign in front of the numbers if it's in the negative sense. That's say leftward and downward. Okay, so that's your problem 1. And we're going to move on to the second problem, which is problem 3. All right, so let's see, problem 3. The x component of a vector A is negative 25, so a sub x is negative 25, and the y component is positive 40 meters. What is the magnitude of A? So you have to find A. And what is the angle between A and the positive x direction? So you want to find the magnitude and the angle. So again, you have the x and y component. You want to draw it on the xy plane. So this is your x and this is your y. The x component is negative, and the y component is positive. So you have the vector that's pointing in that direction, and you're asked to find the angle. So the magnitude is very easy to do because the magnitude is just hypotenuse. It's just the Pythagorean theorem. So you have the square root of ax squared plus ay squared. So when you do that, you have negative 25 squared and then 40 squared, and take the square root of the sum. So you should have the value that is equal to 47.17 meters. Okay. Now, what about angle? So let's say if I define my angle theta here in reference to the positive y-axis, so I'm going to adopt using the small angle convention. So you can see that the opposite, so I have my x component, that's right here, so I'm going to draw here. So this is my x component, that's negative, and we have a positive y component, okay? So in that case, this is your angle. So how would you find your, the theta? So your theta here, we use the tangent, so your tangent theta, you use your tangent theta, your tangent is the opposite over the adjacent. So the opposite here is this. Now, when you use a small angle, and when you want to use a small angle to calculate angle, you have to use the absolute value when you use the tangent. Okay, so in this case, I'm just going to put the absolute, sign, So in the numerator, that will be the opposite. The opposite now is this magnitude. So this is your ax. So that will be your 25. And your y and the adjacent is your y component, which is 40. So when you do this calculation, so your theta prime. So that's called a theta prime. Okay. So theta prime here, after you do the calculation, punch in the calculator, you get 32. But that's not our final answer, because you also find what is the angle measuring from the positive x-axis. This is your theta, okay? So your theta, as you can see, your theta is basically equal to theta prime and then plus 90 degrees. So your final answer is equal to 122 degrees, okay? So the reason why I don't want you to just do the tangent theta equal to negative 2.25 over equal to 40 over negative 25, because some of your calculator does not take into the signs, when in different projects. So it's better just use a small angle, and then look at the right triangle and use the tangent based on the whatever right triangle that you have, and then calculate the value. That value is always, should always be positive value, because you're using a small angle, which is always less than 90 degrees. And above 0. So once you calculate that, and then based on this diagram, you should add 90 degrees to that small angle. So you got 122. Okay, so that's that. Now the next one, we're going to do problem 16. right, so problem 16. For displacement vector, you have your A that's given. So your A is 3i. I'm just going to leave the units out. So 3i plus 4j. And your B that's equal to 5i minus 2j. Okay? Now you want to find A plus B, the summation of these two vectors in unit vector notation, and as a magnitude and an angle, related to the positive x direction. And then you want to find B minus A as well. So you want to find A plus B, vector A plus vector B, and then A minus B minus A. Express that in unit vector notation and then in angle magnitude notation. So summation, because all these are already in unit vector notation. To do a summation, that's very easy because just adding all the numbers in the same direction. You have I here, you have I there, so your A plus B. So your A plus B becomes very easy. That will just be 3 plus 5 I hat, and then plus your 4 minus 2 j hat. So your final answer is AI plus 2j. That's your A plus B in unit vector notation. What about B minus A? So B minus A, just use the B value minus the A value. So your B here is 5 minus 3, that's in the same direction, and then plus -2, and then minus 4 j hat. So you get 2i, and then minus 6 j hats. Okay, so those are in unit vector notation. What about in magnitude and also angle? So let's do the A plus B first. So to do A plus B, again, I will recommend you plot the vectors in the xy plane. So you have A and the x component is 8, and the y component is 2, and they are all positive. So you should expect your vectors to point in that direction. Okay, so in that case, that becomes very straightforward to calculate your theta. So let's just call that theta. So how do we calculate that theta? In this case, you can just directly, this is ready to use right triangle. So your tangent theta is basically equal to whatever that's opposite. The opposite here is 2, and the adjacent here is 8. So that you can calculate your theta after you take the inverse of that tangent. So you get 14 degrees. Okay, magnitude, A plus B, the magnitude, that's called as C. So you have the C vector C, and we call it vector D. So C is basically equal to your A squared and then plus B squared. So you have the x component square. I'm sorry, I should say that. That will be the x component square and the y component square. Okay, so you have your A square and then plus the 2 square. So your C value, you should have 8.25 meters. Okay, so this is for the top one. Now for the second one, because I'm looking for the cap, I don't know where it is. For the second one, again, we're going to draw the xy plane. So you have the positive x. So you have the positive x, and you have the -6. So your vector is right here. So this is your vector D. So the magnitude is very easy. That will be just the x component square and the y component square. So you have the x, that will be 2 squared, and then plus the -6 squared. So after you square it, and then after you add them and take the square root of the sum, that gives you 6.32 meters. So magnitude is very easy to do. What about the angle? Now the angle, because you're asked to find the angle in reference to the positive x-axis, you can define, we can define this angle theta. Okay, so if I define that angle theta, you can see that, again, I'm going to use a small angle. Okay, so you have the x component, so your tangent theta here. So I'm going to use a small, small angle, so everything is opposite value. So the opposite is your y component, so that will be in the numerator. So you have your -6, and then the adjacent one. This is adjacent to the angle. The adjacent one is your 2. So after I use that, you will find that your angle theta here is 71.6 degrees, and that's the absolute value. So then, because it's it is below the x-axis, so your final answer will be that it is negative 71.6 in reference to positive x-axis. Okay, so that's the answer, and then consistent with the pictures that we have here. Okay, so that's basically that. Just this problem just illustrate that when you ask to find the angle, really have to be a little bit careful about which angle that you're asking to find. So draw your vectors on the x and y plane, and then see where which quadrant the vector is pointing, define your angle, and then calculate that angle. And that should be, if you're using small angle notation, it should be a small it should be a positive value. Once you have the positive value, then you can you can add the attributes of the angle. For example, for this one, it's below x-axis, so that will be negative 71.6 degrees below the in reference to the positive x-axis. Okay.